Figure 1 shows an experimental setup of a potentiometer with 4 meters long wire that can be used to determine the internal resistance R of the given cell with electromotive force EMF E. It should be less than E naught. E naught is the cell connected to the potentiometer wire. Part A states two possible qualities of potentiometer wire that affect the accuracy of measurement. We know that when considering potentiometer wire, we are using length of the measurement of the length of the potentiometer wire as the voltage difference. Therefore, now we have to write two possible qualities of potentiometer wire that affect the accuracy of measurement. We can write uniformity of the potentiometer wire. Part A. If it is a non-uniform wire, it is affecting to the feeding uniformity of wire. And we can get temperature of wire. Temperature of wire. When changing temperature, its resistance is changing. Therefore, it will affect to the final reading. Part B. Can the potentiometer shown in figure 1 be used as a voltmeter having adjustable range? Give reasons for your answer. Yes, we can. Yes, we can use it as an adjustable voltmeter. We can change Q variable resistor by changing Q variable resistor. We can use it as an adjustable range. We can use it to adjustable, use to a considered range by changing Q value. See, a student observed a small deflection of the galvanometer when there is no current passing through it. It is admissible to this galvanometer for this experiment. Give reasons for the answer. We are using when galvanometer reading is 0. We can consider the corresponding reading given when current is 0 as a 0, and we can use at the balance point the galvanometer reading should be same as the reading when current is 0. Then we can use here 0th error of galvanometer is not affecting to the reading. In part D, when the switch K2 is open, the balance length of the potentiometer wire is L0. When K2 is closed, the balance length is L. Obtain an expression for internal resistance R of the given cell in terms of L, L0 and R. When K2, you have to observe the diagram. When K2 is open, there is no current through this circuit. R is internal resistance of battery, simple R. E is EMF, guys, and another resistance R. K2 is this switch. When K2 is open, there is no current through this circuit. We know that at the balance point, there is no current through this terminal. at the balance point. Therefore, the corresponding reading L naught, L and L naught. K is closed, the balance length is L. When K is opened, balance length is L naught. Now K is open, K2 is open. Then we can get EMF of battery equals to KL naught. It is the first equation. K is the potential difference per unit length in the potentiometer wire. When K is closed, when K2 is closed, we can get E minus IR is the potential difference of these 2 points. It should be equal to K times new balance length L. Second equation. We can substitute I value before naming the equation. We can use V equals IR to this circuit. When K is closed, the total resistance of this circuit is capital R plus simple r. Then according to V equals IR, I equals V divided by R. V value is EMF divided by total resistance R plus R into simple R equals KL. It is the second equation. Now we have to get an equation for the internal resistance R of the given cell. Now we can divide 2 equations we have obtained. I will divide first equation and second equation. Then E divided by, we can get E as a common factor for these 2 terms, 1 minus R divided by R plus R equals, when dividing we can cancel out K term, L naught divided by L. We can cancel out E. Then I will simplify. LCM of denominators R plus R. R plus R divided by 1. R plus R into 1. R plus R minus R plus R divided by R plus R 1 into R equals L naught over L. We can cancel out plus R and simple R. Then I will bring this term to the numerator. R plus R divided by capital R equals L naught over L. Then we have to subject simple R. I will bring this R value to the right hand side. Capital R plus simple R equals L naught over L R. Then we can subject simple R L naught over L R minus R. It is the internal resistance of the battery. Then part E. When the given potentiometer is balanced, potentiometer, the balance length can be measured with maximum error of 1 millimeter. It means least count of the length measurement, 1 millimeter. If R equals, capital R equals 8 ohms, L naught 72.4 and L 50.1 centimeters, calculate the maximum value that could be obtained for the internal resistance, simple R. We can get maximum value. When considering maximum value, part E, L naught should be 72.4 plus 0.1. This is error. 72.5 centimeters. And when getting maximum value of R, L should be 50.1. It is given answer. We have to subtract 0.1. 50 centimeters. We have to understand for the maximum value of simple R we have obtained, simple L naught should be the maximum value. the corresponding reading is 74.4. We have to add error to get the maximum value. L should be minimum value. Then we have to subtract error from this reading. We can add or subtract error. Therefore, we have to do corresponding mathematical operation. Then I will write the equation R equals L naught over L. It means 72.5 divided by 50. We can use centimeters because of unit is cancelling. Minus 1. I will get R as a common factor. We can write 1 as 50 over 50. Then 72.5 minus 50, 22.5 divided by 50 times R value is 8. We can cancel out by 5, 10, 22 divided by 5, 4, 2 remaining, 25 divided by 5, 5. 18 to 5, 40, 4 remaining, 18 to 4, 32 plus 4, 36. We have to separate one decimal place and we have to divide by 10, 3.6 ohms. Then part F, internal resistance R can be determined more accurately by a graphical method. Considering capital R as the variable resistor, rearrange the equation obtained in part D to plot a suitable graph. Write down the independent X and dependent Y variables of the graph. The equation we have obtained in part D. Simple R equals, capital R is a common factor, L naught divided by L minus 1. Capital R is a variable resistor. We can change it. Therefore, we have to get a physical quantity related to capital R as the x-axis. And we have to measure the corresponding L value. And we can get measurement of L, a physical quantity relative to L as the y-axis. Then we can subject the L term. I will expand the bracket. No, I will bring capital R to left hand side. R over capital R equals L naught over L minus 1. Now we can get L over L naught equals R times 1 over R, then bring minus 1, we have to put plus 1. Then we can get, it is in the form y equals mx plus c. We can get x value, independent variable, 1 over R, y value, dependent variable, L over L naught. Now, in this equation, L naught over L. And then part G. The potentiometer circuit shown in the figure. One can be modified by replacing the part of circuit marked X in the figure 1 by the circuit shown in the figure 2. Marked X, it means galvanometer circuit. You have to replace it by using the given circuit in the figure 2. For these terminals, S dash and T dash of the circuit shown in figure 2 are connected respectively, point S and T to the potentiometer circuit shown in the figure. Part 1. Before getting part 1, I will draw the circuit to explain. This is an operational amplifier. It is a special circuit, IC, integrated circuit. We are studying in electronics lesson. This is the integrated circuit. The name of the integrated circuit is operational amplifier. This is a LED. It is a green LED. And there is a resistor. In this part, there is a red LED. And there is a resistor. Red LED, green LED. This terminal is earth. Then S dash, T dash. Then I will read the first part. Assume that the balance point is located between A and B. The modified circuit, what is the color of LED emitting diode, light emitting diode, which is lit when the sliding key is placed at A and B. When sliding key placed at A, it means left hand end, end of left hand side. Then potential of S means sliding key, is greater than T. You have to consider S and T points in the circuit. In the circuit, it is like this one. T is this point. And sliding key is connected to S. Now T and S should be connected to this circuit. When sliding key at this end, we can consider that there is a current flow through the potentiometer wire. Now I will consider that K2 is open. Then we can consider that if this circuit, if this terminal is an earth terminal, potential of this point is less than this point because of this is the plus terminal of battery. Then potential of Vs is greater than Vt. S terminal is connected to this part. Therefore, this operational amplifier is plus saturated. It means there is a plus output in this terminal. Therefore, green LED will lit. Green LED will lit. We can get opposite logic. When S is at this end, right hand side end, Vt is greater than Vs. Therefore, operational amplifier is minus saturated. Then red LED will lit. When the circuit is minus saturated, it is giving a minus output voltage. If this voltage is minus, there is a current flow through the red diode. This is at A and this is at B. In part 2, briefly explain how the balance point could be found using modified circuit. At the balance point, both of LEDs are not lighting. Then we can write answer for part 2, G part 2, both LEDs are not lighting at the balance point. Part 3, state 2 advantages of modified circuit in finding balance point when compared with circuit shown in the figure. In the figure 1, there is a galvanometer circuit. We can write answer for part 3. We can identify balance point clearly. There is only one situation, only one balance point. For the circuit, we can obtain it correctly. Both LEDs are not lighting. And we can give another reason, another advantage. There is no risk to burn circuit. You know that when using galvanometer, we have to consider the current through the galvanometer such that it is not burning. But in this circuit, there is no risk to burn the circuit.